Welcome back to Cyber Science, and welcome to our first keynote session of the day. It's my pleasure to introduce Dr. Ramesh Ramadoss. He's a technical director at Interwork Alliance and a co-chair of the IEEE Blockchain Initiative, and also an expert panel member of the EU Blockchain Observatory and Forum. We have a pre-recorded presentation from the speaker, and he will join us in the middle of the recording video just for a live Q&A. So if you have questions throughout the presentation, please pop them into the Q&A feature you see at the bottom of the screen, and we'll discuss that at the end. Thanks.
IEEE Cyber Science Conference. Hello, everyone. My name is Ramesh Ramadoss. I serve as a co-chair of the IEEE Blockchain Initiative. I'm also working on a blockchain startup. Thanks for inviting me to speak at the 2021 IEEE Cyber Science Conference. Today, I'm going to talk about the blockchain evolution, ecosystem, and the landscape. Okay, here's the outline of my talk. We have 6 sections. We'll start with the Bitcoin history and fundamentals. Then we'll look at the blockchain landscape. After that, we'll look at the startup ecosystem, enterprise ecosystem, and some government use cases. Finally, I'll share with you my perspective on the future of blockchain. Let's start with the first section. When you hear a talk on blockchain, you'll hear this word trust quite often. So let's put that in context. As you know, social trust is the underlying foundation of all relationships. Social trust can be categorized as interpersonal trust and institutional trust. What's relevant to our talk today is the institutional trust, which is the confidence of citizens and institutions such as banks, governments, and corporations. As we all know, the 2008 economic crisis was caused by financial institutions. People lost trust on these institutions. We don't have much of a choice. Our financial system is run by these centrally controlled institutions. One might ask a question: is it possible to run a financial system that does not depend on a centralized institution? Enter Bitcoin. It is an electronic cash system that does not depend on a centralized institution. The idea was published back in October 2008 by Satoshi Nakamoto, who was an anonymous person. And in January 2009, the Bitcoin software was launched. Interestingly, that person included a note about the financial crisis in the first block, Genesis block of the Bitcoin software. We'll talk about what a block is shortly. Now, let's talk a little bit about Bitcoin. Actually, the idea did not come out of nowhere. Bitcoin was a fusion of several key ideas from cryptography, consensus protocols, and peer-to-peer networks. Satoshi's genius was in creating this recipe with all these ingredients you see on the left side: Merkle trees, timestamp, proof of work algorithm, secure hash algorithm. On your right side, you would see Bitcoin predecessors. There were many attempts before Bitcoin to create an electronic cash, but Bitcoin is considered to be the first successful electronic cash deployed on a decentralized peer-to-peer network. Now, let's look at some fundamental concepts such as block, ledger, blockchain. So a block consists of a batch of transactions, and each block is linked to the previous block by cryptography through hashing. Hashing algorithm is used to map arbitrary size data into fixed values. And a ledger is actually a chain of these blocks. And the protocol allows only addition of blocks. It's immutable. If you really want to see the demo at the bottom, you see the visual demo of how this works. Now, this chain of blocks, called a ledger, is replicated and stored across many computers on the peer-to-peer network. And that's why it's called a distributed ledger. It's distributed across many computers. A user running a node on the network can actually initiate transactions and send Bitcoins from his or her wallet to another person on the node on the network. Now, miners are the ones who validate these transactions and record them on the ledger. Now, we'll look at a few more details of how this process works. So a new block is added to the blockchain every 10 minutes. Miners propose new blocks and compete to earn the reward. Like you see at the bottom, we show 3 miners, and they're all proposing blocks, and they're all competing to earn the reward. The competition involves solving a mathematical puzzle using the proof of work algorithm. That is, you have to guess a number below the target number for that particular block. The miner who proposes the winning block receives a reward, new Bitcoins, plus transaction fees from that block. So now you can see the longest chain, the ones that are shown in green, becomes the valid chain, and the miners start working on the longest valid chain. Now let's talk about mining reward. Bitcoin was created with a limited supply of 21 million. The only way to create new Bitcoin is through mining. As of May 24th, the mining reward could be as high as 220,000 for adding a winning block. And now it's 6.25 BTC or Bitcoin. Now, you may be tempted to do mining, but it's not that easy nowadays. In the beginning, you could mine Bitcoins on your home computer or laptop, but unfortunately, Bitcoin was programmed with a difficulty factor such that the computational power required to mine Bitcoin increases over time. So now, Bitcoin is predominantly mined by mining pools, which are centralized computing warehouses, or called mining rigs, that you see on the top right corner. Now, at the bottom, you see a pie chart that shows the centralized mining pools. So even though the map shows you over 9,700 nodes, supposedly peer-to-peer nodes, now are under the control of centralized mining pools. And these mining pools are running these guessing game and trying to be the winner and running all these hashes, the hashing algorithm. And if you look at the graph at the bottom, they're running like 150 million tera hashes per second. And you can imagine the energy consumed by these hashing exceeds the energy consumed by some countries. Like you can see at the top, that shows the energy consumption. And this has been a concern, real environmental concern. And if you look on the right side, Tesla back in March of 2021, they said they would start accepting Bitcoin, but later on in May, that tweet shows that Tesla announced that they're going to stop accepting Bitcoins due to the concern of the cost to the environment. Now, let's look at the price of Bitcoin. So this graph shows you the price all the way from 2013, but when Bitcoin was launched back in January 2009, it had no value, almost zero value. Nobody cared back then. And then since then, the price has been primarily driven by speculation. And you can see last month on May 8th, 2021, the price was peaked at 59,000. And May 13th, Tesla, that announcement we talked about, the tweet about Tesla stopped accepting Bitcoins. Then May 21st, there was a news, you see on the right side, there was a news from China that they're going to crack down on crypto mining. You saw those mining pools that we talked about. There are quite a few mining pools located in China. And within like 2 weeks, like May 23rd, the price crashed 40% to 33,000. In summary, you can see Bitcoin is highly volatile. Now, as a summary, the original idea of Bitcoin was to serve as a digital cash on a decentralized peer-to-peer network. However, over time, Bitcoin has become a highly speculative digital asset, not stable like cash. And number two, Bitcoin has come under the control of centralized mining pools. Even though the mining pools are distributed, they're owned by centralized companies. So they're not under the control of decentralized peers anymore. So you can see these two kind of like goes against the original philosophy of Bitcoin. However, all in all, Bitcoin set the stage for the blockchain revolution. So we will look at that in the next few slides. Okay, we will move on to the blockchain landscape, evolution, some use cases. Bitcoin gave birth to a new field called blockchain, as we talked about on the last slide, and that has gone through 3 stages of evolution. Blockchain 1.0 is essentially the launch of Bitcoin and altcoins that are like Bitcoins, and blockchain 2.0 refers to programmable chains such as Ethereum, Corda, Hyperledger Fabric. And the third stage of evolution includes several new architectures, including DLT, DAG, that aim to address the limitations of blockchain 2.0, such as scalability issue, interoperability issues, and so on. You know, blockchain is a collection of many different architectures. Like, you know, we talked about 1.0, 2.0, 3.0, and DLT, DAG. It's like a toolbox. You have many tools used for different purposes. So it is challenging to make a general statement about blockchain. One way to understand what's happening here is to look at technical functionality. So you can do 3 things: data storage on the ledger, computing, that's number 2, and then communication, that's number 3. And many use cases have been built by utilizing one or more of these functionalities, such as digital asset on an immutable ledger, provenance, you can track things because it's immutable, and autonomy, smart contracts enable autonomy, and multi-party computation, machine-to-machine transaction, and so on. Now, we will look at the crypto community and the startup ecosystem, and this section is going to be a little dense in the beginning, and once you get through that, the rest of the talk is going to be easier to follow. In the next 3 slides, I'll introduce some new terminologies so you can understand the rest of the talk. So please look at the architecture comparison at the bottom. The green box you see shows the protocol layer, which is at the core of a blockchain DLT architecture. That's the main differentiating factor between different architectures. So now cryptocurrency is a native asset that is programmed at the protocol level. And you need to have this cryptocurrency or native asset to run or execute transactions on that blockchain. For example, in the case of Ethereum, it's Ether or gas. Here we're going to learn about 2 more terminologies: smart contracts, which is actually a computer program that's run on the virtual machine of the blockchain. And it basically records, the outcome is recorded on the blockchain. It's pretty similar to a normal computer program with if and then conditions. And in this case, if it executes, it's going to transfer some asset from one account to another account. And it's also sitting on a decentralized computer network. Now, tokens. Tokens are basically a digital asset created by a smart contract. So it's actually a programmed digital asset. So 2 terminologies on this slide: smart contracts, tokens. Now, the fifth terminology is dApps, decentralized applications. So you can see in the red box on the architecture, the top layer is the applications. So decentralized applications are built using one or more smart contracts and also with front-end components like the JavaScript, HTML, CSS. It's like a typical web app that we are familiar with. Well, the difference is the backend uses the blockchain stack, but the front of it, we can't really tell the difference. Now, using the features we just discussed so far, like we talked about protocol, we talked about smart contracts, we talked about native asset, and we talked about dApps. An entire ecosystem has been built on top of Ethereum blockchain. You can see thousands of projects focusing on scaling, infrastructure, exchanges, analytics, and so on. So this is just one blockchain. So now there are thousands of blockchains. We'll talk about that shortly. Now, this slide shows the evolution of crypto asset or digital asset. You can see 2009, Bitcoin inspired the launch of several altcoins, and the volatility of Bitcoin price led to the launch of stablecoins. We will talk about it later. And the launch of Ethereum programmable chain inspired the launch of many other chains, and also served as the test bed for a lot of experimentation such as ICO, IEO, STO, DeFi, NFT. And as a whole, these items inspired corporations like Facebook launched Libra Dime project, and governments are looking at CBDC. We will talk about those red items towards the end of the talk. Now, this slide shows the entire crypto ecosystem market cap, total market cap. So obviously this is not complete, but you can see the logos of hundreds of projects there. Maybe. But if you go to coinmarketcap.com, it's a website, you can actually see as of June 5th, there's over 10,296 coins listed there. It could be a combination of native asset protocols that we talked about, or it could be tokens programmed at the top of the protocol. So that's the difference. Native asset is at the protocol level, and tokens are actually programmed on top of the protocol or chain. So combining all of those, the total market cap is about 1.65 trillion as of June 5th. So you can see it is likely that many of these projects would fail. In fact, a lot of them have already failed, but in the future, many of these could fail. However, it is very unlikely that the entire ecosystem, would collapse to nothing. So blockchain is here to stay. You will actually see more in the next coming slides. Now, we talked about stablecoin, launched because folks were not happy about the Bitcoin price and volatility. So the price of a stablecoin is pegged to a fiat, for example, the US dollar, or a commodity, example, gold, like Digix is a gold-backed token, or it could be even back to another crypto. And so why this is interesting is when price of Bitcoin drops, people tend to actually sell Bitcoin and move their asset into stablecoin, and then they move back later, when the price is starting to go up. So, and now you can see there's over a dozen stablecoins, and it's been gradually increasing over time. And now the total market cap is about 100 billion, which is about 6% of the total market cap of the entire crypto ecosystem. Now, we'll talk about some interesting topic here, initial coin offering. So you may recall that I mentioned that tokens are programmed using smart contracts. Initial coin offering is a way of selling tokens by startups. And they were raising funds for their startup idea. And basically, any startup team from any corner of the world with a white paper outlining their idea and the product roadmap and a website, they were able to sell tokens. It's the same computer program. It's a piece of code called ERC20 token standard on Ethereum blockchain. And you will see on the next slide, billions of dollars were raised. And just to give you an example, why would someone buy these tokens? you see the example, I put example startup XYZ token. So the way, it's just a scenario how this works and why people buy these tokens. Like private sale, seed investors might buy these tokens, or the startup team would convince them to buy their tokens for, let's say, 10 cents per token. And then after the private sale is over, and then they go do a public sale, sell these tokens to anyone in the world. And people who are buying these tokens typically are buying using Ethereum or Bitcoin, and exchange, they get these tokens. And when they list these tokens on the crypto exchange, it could be $10, or it could crash to 1 cent. Of course, people who bought these tokens were hoping they will be 10 or even 100 so they can catch these tokens. However, it could be 1 cent per token. So this actually triggered a lot of response worldwide. Between 2017 and 18, startups raised over $34 billion issuing tokens. These are different startups, thousands of startups. And some startups disappeared immediately after fundraising. They were outright scams. They had pretty pictures and white paper and all that nice website, but then when the token sale is over, they get their Bitcoin, Ether, the cash, and the Twitter is down, everything is quiet. So in some startups, they tried to build the product outline in their white paper, and after 6 to maybe 8 months, they eventually gave up because they ran out of funding. They couldn't deliver what they promised, which is not that bad. And a few built and deployed live projects. So this unregistered fundraising by startups triggered a global response from various countries. Now, some countries were just banned it, basically India and China. If you do an ICO from China, you can go to jail. And now India, they're talking about a bill that you could go to jail for 10 years for ICO or even trading Bitcoin. I don't think it's a law yet. It's it's under discussion. And then some countries issued warning, like Securities Exchange Commission in the US. They issued cease and desist letter to some of the ICOs, and some ICOs, in fact, they refunded the money back to the investors because it's unregistered. They don't follow the existing regulation. However, some countries, small countries, nimble, they actually designed, some new regulatory framework so where you can actually follow the system and do an ICO. As an example, Singapore and some countries like Estonia and Europe, Switzerland. So you can see that map, but the amount of money raised was astonishing, $34 billion. In addition to this, crypto blockchain investment firms specializing in investing on crypto blockchain startups, so they were doing all the due diligence, and they make sure they are legit, and and they're still, this data is pretty recent, so these top companies are still investing in this space. Now let's look at the dApps, decentralized applications built on public blockchains. So there's a website called dappradar.com. If you go there, they list dApps built on many blockchains like Ethereum, EOS, and VAX, and many blockchains. So there's thousands of dApps there. And if you look at the majority of the dApps deployed on blockchain fall in the category of games, gambling, exchanges, DeFi, NFTs. And now if you look at the users, I have a column users. For example, the top one, the Alien Wolves, and it was like less than 2 million users. So overall, dApps based on blockchain still struggle with mainstream adoption. Now let's look at two hot topics in the crypto blockchain, public blockchain space. One is DeFi, and the other one is NFT. So we'll talk about those two things now. So DeFi, decentralized finance, is actually a peer-to-peer financial system that is entirely on blockchain. Remember in the beginning, we talked about this Satoshi Nakamoto's dream of creating a peer-to-peer cash. Now, DeFi is about creating a peer-to-peer financial system that is running entirely on blockchains. So it's the services that they offer are pretty similar to what we are familiar with: exchange, lending, or borrowing, giving your asset like house and take a loan. So all those things are pretty similar, but here, all those operations are done on blockchain, and you're dealing with crypto assets. Just to give you an example, so if you have crypto assets, like you have Bitcoin or Ethereum, there are apps that actually you can go, get a loan with your crypto asset, or you can even receive interest income on your crypto asset. And if you look at the total value locked on, we're talking about smart contracts running these DeFi protocols, about $80 billion. And there's a website, DeFi Pulse, that tracks all these projects, and it even shows you the interest you get for your crypto asset. Now let's move on to the hot topic in 2021, NFTs. In fact, recently there was an episode on Saturday Night Live about NFTs. So the field of NFT started with the introduction of ERC 721 token standard, which is basically a smart contract code. And you can actually issue a unique digital asset. So it could be a photo, audio, video, or any digital file. And you can issue a token for that. And these are unique, they're not exchangeable. You can buy them, but they're not exchangeable one-to-one. It's not like Bitcoin. One Bitcoin is same as another Bitcoin, but one NFT is not same as another NFT. So now this is pretty hot right now, and you can see there are the pie chart shows different kinds of NFTs like art, collectibles, and primarily in the digital domain. And the market cap has been growing. I can see as of 2020, it was like 338 million, and I think now it's even higher. Just to give you a couple of examples on this topic. So back in March of 2021, a digital file, a JPEG file, was sold for $69 million, right? So again, this was sold through Christie's auction house, a traditional auction house. And now after this, many auction houses are interested in doing NFT sales. In fact, I think eBay announced that they're going to start selling NFTs. Now, also, there's a company called NBA Top Shot. They teamed up with NBA, and they actually sell NFTs for top shots from NBA. And now they have about 1 million users with a revenue of over 700 million. Now, there's even a bigger vision by folks that are working in the blockchain industry, creating this decentralized internet architecture. And in order to create a decentralized internet architecture, you need several components to be decentralized, such as, you can see the boxes: decentralized storage. There are some projects working on it, and computing, messaging system, domain naming system, and browsers, and of course, dApps we talked about. So the idea is to actually create a decentralized internet that is not controlled by any single authority. Censorship resistant, nobody can bring it down or block this internet. Now, the red box shows you some of the active projects like Web3 Foundation and Tron and Internet of Blockchain Foundation that are working on this architecture. Now, there are more decentralization theme-based projects like decentralized identity, voting, registry, social networking platform, Wikipedia, and the list goes on. Let's talk about the enterprise ecosystem, and then we'll look at the government use cases. Okay, last year, Forbes published this Blockchain 50. Here they list 50 big companies working on blockchain. And there's a company called Block Data. They actually took that 50 list, did grouping based on the use cases. And you can see the use cases. It's pretty interesting. Capital markets, and you have supply chain logistics, and banking and finance, payments. And so these are some of the use cases. The same company, Block Data, now I think it's part of CB Insights, they took this top 50 and they started categorizing them. You can see the vertical columns based on the infrastructure used. So at the bottom, all the way at the bottom, x-axis, what you see is the infrastructure, meaning the blockchain or DLT technology that's used by these companies. So the top 3 infrastructures used by enterprises turns out to be Hyperledger Fabric, Ethereum, and Corda. Now, enterprises are coming together and joining forces to create alliances and consortia. They focus on building private blockchain infrastructure, standards, industry standards and specifications on vertically focused areas like supply chain or transportation and so on. ESG Intelligence published a market report, and they say there are 433 blockchain consortia. So they all focus on different aspects. For example, Mobi that you see here, they focus on auto industry, and BIDA is used to be called Trucking Alliance, but now it's called Transport Alliance. So they're it's an alliance of all these companies involved in transportation. Now, enterprise blockchain as a service. So leading cloud service providers such as IBM, Microsoft, Amazon, Oracle, they all added blockchain as a service platform to their existing cloud service. And the bottom ones are companies from China, Tencent, Baidu, and Alibaba. Okay, now this slide shows several organizations working on developing blockchain standards, specifications. You can see 4 quadrants here, the top ISO, IEEE, ITU, and there are the standards development organizations. And at the bottom, alliances and consortia that we just talked about on the previous slide, they're working on creating standards. They're referred to as private or industry standards. And then on the right side, we have the the open source community that Bitcoin, Ethereum, they're all creating this specifications, or they call them standards, but their specifications are coding specifications. And also there's open standards organization, W3C, IETF, Oasis, they're also working on blockchain standards. So you can see it's pretty vibrant, and the enterprise ecosystem is maturing. Now we'll look at the government use cases in the next section. So European Blockchain Services Infrastructure is a blockchain project funded by the European Commission. The goal of this project is to build a common public infrastructure for cross-border public services. They are focusing on some use cases such as identity, data sharing, diplomas, and notarization of documents. Just to give you an example, like a person with an identity in one country, like say, for example, Germany, if they move for job or school to a different country in Europe, they have to get a new identity from the second country where they're moving to. So they're trying to solve that issue by this common infrastructure. Similar thing applies to degrees, diplomas. You get a degree from one university, they want to be able to seamlessly prove that they got it at another school. Now, China is somewhat similar project. It's called Blockchain Services Network, BSN, and many companies are involved in building a similar common infrastructure. Now, last year, United Nations published a guide outlining some blockchain use cases, such as land record management, supply chain, tracking food, and minimizing food wastage during transportation, and cash transfers in refugee camps. Now, let's talk about hot topic in the government sector. Central bank digital currency, or CBDC, is basically a currency issued by central banks on blockchain or DLT. It'll serve the same purpose of current cash system, but here there's no need to print paper money and distribute. So as a result, there's cost reduction, and there's also financial inclusion. It's easy to distribute cash as long as they have a mobile phone. And then of course, it's easier for government to collect taxes and track money laundering. So that's why governments across the globe, as you can see on the map, are running pilot projects or CBDC. And in fact, US has a project called Digital Dollar. And China, actually, they did a pilot last year with Starbucks and McDonald's. And according to PwC, 86% of central banks worldwide are conducting research on CBDCs. Okay, now it is interesting to note that Bitcoin was launched in a small online community called Cypherpunk. And now, 10 years later, enterprises are talking about creating a corporate currency like Libra Dime that's backed by Facebook. And then now we talked about it on the last slide, and governments and central banks are talking about using blockchain for issuing digital currency. So you can see in 10 years, how things have evolved, and a lot of the experiments happened in the crypto ecosystem, which was primarily driven by speculators. It funded these projects, and experimentation led to something that's happening in corporations and governments. Now, let's talk about the future of blockchain, which is the last section. So if you look at the Gartner hype cycle, since 2014, they've been tracking, cryptocurrencies and blockchain, and they publish this hype cycle around July, August of every year. And last year in 2020, this graph was published, and there was no blockchain. What happened to blockchain? Well, to answer this question, we have to look at the Paris technology life cycle. So according to Paris, any new technology tends to follow an S-curve, starting with the installation stage, and then it moves on to the deployment stage. So as we have seen throughout my presentation on things happening in the startup space and enterprises and governments, central banks issuing CBDCs, now blockchain has clearly entered the deployment stage. Now, what's next? So in the near future, blockchain in combination with artificial intelligence, big data, and IoT is going to create new business opportunities. In fact, I put a few emerging topics on there, between these intersecting areas. If you look at the one at the top, chain data analytics, it's actually a company was started back in 2014, and they've been actually tracking, the transfer of Bitcoins. And now, that's been going on for a while. But some of these areas like IoT machine-to-machine transaction, IBM did an experiment on that, and there's a lot of companies working on that as well. And then recently, Nokia announced a marketplace that actually combines all of these technologies I just talked about, machine learning, IoT, data monetization. We talked about tokens, so you can actually tokenize data and for trading. That was my talk, and thank you for listening. And you can actually find me on LinkedIn, and please do check out the IEEE Blockchain Initiative website.
All right, thank you very much. Sorry, I'm having troubles with starting the camera. So Alicia, can you let me share my webcam, please? In the meantime, there are a couple of questions there in the Q&A. So thanks, Ramesh.
Do you hear me?
Yeah.
Make sure the audio is fine.
Yeah.
Okay. Yeah,
we can hear you, although you are in space.
Okay. Yeah. Let me share my slide here. Let me see if I can. Do you see my slide? I wanted to answer the question that I think it's Cyril. This is regarding the mining pools. So the mining pools are located, this map doesn't show, a lot of mining pools are in China. And if I actually zoom this thing, let me see if I can bring it to the front. So you can see, if you add up like 3 or 4 pools, they kind of it could sometimes be more than 50%. So to answer your question, Cyril, this was not the original intention of the person who created Bitcoin, but over time, these companies were created to actually own these mining warehouses, and you can see these ones here. I mean, let me see. So these are like mining warehouses, and it requires a lot of investment. And basically, over time, it has become centralized. And again, Bitcoin has its drawbacks, like the energy consumption is one main issue, and the other thing is the decentralization. Well, it's now centralized, but many other architectures were explored. Like if I were to show you, just to give you an idea, we'll go to that slide. So you can see this slide shows a comparison of the energy consumed by Bitcoin. If you were to compare it to, this Tower Khalifa, and that's just for one transaction, right? And the energy consumed by Ethereum. So Ethereum was actually launched, was inspired by Bitcoin, and Ethereum power consumption as of today is about 84,000 watt hour, and they have another Tower of Pizza as an example, like to compare with this. Now, Ethereum is actually moving to a different protocol called proof of stake. When they move to proof of stake, and their energy consumption is going to go down significantly. So one of the main things that energy consumption depends on the consensus protocol used in the blockchain DLT architecture. And you can see on this slide, since the launch of Bitcoin was launched using proof of work algorithm. That's actually this one, right? And then over time, thousands of hundreds of experiments, right? You saw several blockchains were launched with different consensus protocols, and so things have changed a lot. Of course, the thing about Bitcoin, there's nobody updating Bitcoin. It just keeps running, and that's the issue. But other chains, like for example Ethereum, the people are still around. The folks who actually launched the Bitcoin, they have a foundation that actually is constantly working on upgrading, updating, and as I mentioned earlier, they're actually moving from Ethereum. When they launched Ethereum, they used the proof of work algorithm that was used in Bitcoin because it was proven. So they just took something that was already proven, and they used proof of work algorithm, which actually consumes a lot of power. But then now they're moving into proof of stake. It's actually, you can see here, that's the second one. They're moving from proof of work to proof of stake. And then that's for energy consumption. And now talking about decentralization, the issue we talked, you raised about mining pools or centralized. So some of these algorithms use like some randomness in the, mining selection of winning block. And so in summary, right, these different architectures have been experimented the last over 10 years, 12 years, and some are just to, here's an example. Like for example, this one shows you that just comparing Bitcoin, Ethereum, and Cardano. Cardano is a blockchain like I talked about blockchain 1.0, 2.0, and 3.0 in the beginning. If you recall, all the way in the beginning, I kind of like outlined how you can understand the evolution of blockchain. And you may recall this one where there's 3 stages of evolution. So this slide that I'm showing you actually shows you one example from each 1.0, 2.0, and 3.0. And that kind of gives you an idea that people have been experimenting, constantly improving, and things are evolving in the space. And going back to that slide, you can see the energy consumption for Bitcoin was very high. Ethereum was lower, but as I said earlier, even Ethereum is moving towards better, proof of stake. And Cardano, you can see that it's like really low. I mean, it's like factor of what, even 10,000 lower than Ethereum. So there's a lot of experiments going on in this space, and some are, there are even algorithms now called, there's one called Algorand, and that's actually using randomness in the selection of the peers who would validate the blocks. That actually prevents the decentralization. And it's interesting, if you look at this one, like delegated proof of stake, they use they delegate, it's almost like, we elect, politicians, right? For some region, right? We elect somebody to represent that region, and that person goes and, parliament, they represent that region. So delegated proof of stake kind of works like that, community with tokens, they choose the miner, and then there's 21 miners, they get to actually decide the next block. So I just wanted to throw this out there. You can see all these algorithms, they have different ways of dealing with consensus, and then also in terms of dealing with the centralization versus decentralization, and also the energy consumption issue.
Okay, and then I'd be curious to know what's your view with regard to what can happen at the interplay between quantum computing and blockchain. Essentially, there is a bit of discussion regarding the fact that the use of quantum computers might actually crack the encryption.
Yeah.
So I'd be curious to see what's your view on this.
Yeah, so there are some projects that are actually quantum proof. Yeah, sure. Many blockchains won't survive the quantum computing, which crack the algorithms used, but there are some quantum proof algorithms that, if you really want to know, I can send you the list of projects that they're working on. Bottom line is, some of them might fail if quantum computer takes off, but not every project would fail. And I think there's also an evolution. It's, the community that are still active, they would actually update the algorithms, and there's always going to be constant updating of they call it forks. Yeah.
I think the challenge there is that probably easier to do on private or consortium blockchain than fully public blockchains. That's probably the potential challenge.
It's easier, but interestingly, some of these public blockchains have been upgrading and doing hard forks, and of course there are issues with that. I don't think I have time to get into forks, because when they fork in a public blockchain, then you kind of split the community. Some people stay with this, they don't want to change. It's like making a decision, when you have like 10 people, they make a decision, 5 people go to one restaurant, the other 5 decides to go to another restaurant, right? It's a similar kind of thing. It's there's a community of 10,000 or thousands of people on a blockchain community, and this fork, when the update happens, some folks, they don't want to upgrade, they just want to keep running the old programs, and that's where you end up having like 2 or 3 or multiple forks.
Mm-hmm.
Yeah.
There's another question here in the Q&A. Very interesting keynote. What are your thoughts about using DL for identity protection on a large scale? At the moment, many companies and service providers still use things like address, social security numbers, etc. But a lot of this information was compromised by data breaches. Yeah,
so there's a lot of projects. There's like probably 25 projects on. There's actually a website that tracks all the identity, decentralized identity, or identity on blockchain. And as I actually talked about in my slide, European blockchain infrastructure. They're building it with the goal of issuing identity on blockchain. So I mean, it's still under progress. There are some issues with that as well, because there are still issues that needs to be resolved. Like, I mean, even if the identity is on blockchain, there are like life cycle, like, what happens when somebody passes away, or somebody, there's some kind of mistake, or how do you correct it? And you still need some sort of governance, like who can actually make the changes, on these things. So yeah, there are some issues. There's a lot of work going on, and I haven't seen any. I think the biggest deployment would be the European Commission's project, and let's see what happens. I haven't seen anything else like big in a big way. So let's see what happens with the European Commission's effort.
Then another question there, following Cyril's question, previous question, is at this conference, Professor Ross Anderson was our keynote speaker on the first day, expressed the view that blockchain is not decentralized, with hardware, software, and management and financial aspects being narrowly held. What are your views on this? Is research being done into measures or into compliance regimes to ensure this decentralization?
Yeah, so again, the funny thing about this space, as I told you earlier, it's like a toolbox. Any statement you make, it's hard to make a general statement. Like, as we talked about, like, Bitcoin has become decentralized over time. Originally, when it was launched, the thinking was like each peer would be someone else, right? Not like one peer running like multiple nodes. It's like, the idea was like, I have a computer, I basically become a node and I validate transactions. But if it makes financial sense from mining, then I start buying, running 10 computers, 100 and 1,000. That's how the mining pools happen. Now, Bitcoin, as things have evolved like in that direction, but and then even proof of stake. If now with algorithms such as proof of stake, there is an argument that a lot of the proof of stake, how it works is like whoever owns more tokens, they get, they can vote on the outcome of the decision. So even that seems like it could be centralization. So, and there are projects like I told you about, Algorand and a few other projects. They kind of fall on this third generation blockchains where they use randomness. So that really prevents centralization. So yeah, I think at the point that it's gone, so I can see like, yeah, I mean, there were like studies where even the assets held were like primarily centralized. Like only very few people, you can actually, it's public. If you just search on Google, just say, Bitcoin, Wales or something, and largest holders of Bitcoins, and you would find out it's like very, very few. I mean, you wouldn't know who the persons are. It's anonymous. Just you can see the address that that holds a significant amount of Bitcoin. So you can now say, oh, it's kind of like the wealth is also centralized, and the mining pools are centralized. Anyway, so the thing you have to understand is like, if you go to coinmarketcap.com, the good thing about all these open source projects, every open source project that the token, you can actually see that listed on the CoinMarketCap. And different projects are still experimenting with all these different protocols, and things are still evolving, and it's a very dynamic space. Yeah.
Okay, that's great. I don't see any other questions there in the Q&A. So And thank you very much, Ramesh, for taking the time to joining us today. I know it's early morning where you are, so I really appreciate it. And thanks for the very interesting insights. And thanks also to all our attendees for attending this session. The next talk is going to start at 4:30 p.m. UK time. So we have a half an hour break, more or less. So I hope to see many of you there.
Yeah, I will just tell everyone to check out this website, blockchain.ieee.org. And there are a lot of projects that are happening in the blockchain industry, like the IEEE. Thanks. Thank you. Thank you, everyone.
Perfect. Thank you very much.